Today, drawings can be automated using iLogic or the Inventor API. And actually, in the previous webinar, I talked about what iLogic really is. And to me, being a user of iLogic for 10 years now, I find that iLogic essentially it's a window to the Inventor API. It's a way to access it. I think of iLogic, particularly the rule editor inside of iLogic, as an IDE or a design environment, a development environment for our code to do things with Inventor files, be it IAMs, IPTs, or IDWs, DWGs, whichever. So when it comes to working within the drawing environment, there are very specific tasks that need to be done when it comes to developing drawings. So what I'm going to do, let me go over to Inventor here first, and we'll come back to that slide. And I'm just going to open up an existing drawing that I've created before using my automation here. And this is a standard drawing. Most everybody should be familiar with some of the basic constituents of this particular drawing. We have a border, we have a title block, we have a parts list, we have a sheet size, we have some views, some dimensions, some annotations, and some balloons. So most 2D documentation really comprises of these very elements right here. So how do we approach those? If we know that these are the elements that belong to a particular drawing, how do we manage them? How do we work with them? So what I've done is I've created a series of iLogic rules as a fast way of being able to demonstrate the power of drawing automation. Okay, so understanding that we have to work with sheets and we have to work with views and dimensions, let's go back over here to the PowerPoint and I'll kind of express a little bit more about what all that means. So from my experience, there are some very simple things to do when it comes to developing drawing automation. And then there's some things that are not so simple or rather difficult things, simply because of the nature of how human beings interface or interact with drawings. So when it comes to developing drawings, we know that we have to have sheets. And a drawing package might have a single sheet. It may have numerous sheets. So we need to be able to quickly be able to generate the number of sheets that we need in order to satisfy that particular package. Once we have sheets, then we can start placing views, and we can scale those views, and we can adjust if they have hidden lines, or if they're solid, or what the orientation might be, or where it's positioned on the sheet. So bringing up views, let's understand also that there are particular dependencies between these different elements when it comes to drawing automation. And what I mean by that is there's no way for me to lay down a view if I don't already have a sheet first. There's no way for me to place dimensions if I don't have a view first. So understanding that correlation between these elements within our drawing environment is absolutely essential. You have to know how Inventor works when working within the drawing environment and what those dependencies and those requirements are before you can even approach some level of drawing automation. So simple tasks within drawing automation, being able to quickly generate sheets. Once those sheets are created, laying down different views. Once those views are created, then we can start generating a parts list from those views, as well as any sketch symbols, even though those aren't necessarily dependent on anything aside from a sheet. We have to have sheets down before we can start placing sketch symbols, okay? So isolating the simple tasks versus the difficult tasks, those difficult tasks being placing dimensions, and then of course identifying components that we want to balloon. Now the reason why I broke it down this way is because if you approach a drawing automation project, or rather, let's take that a step back. If you approach any type of automation project, there are going to be low-hanging fruits, right? Where If I do this one thing, I'm going to invest a very little amount of time and effort, and then it's going to net me a particular benefit. Okay. And then there's the more challenging thing. Sometimes I have to apply a lot more energy, a lot more planning, a lot more effort, and maybe sometimes even applying that much effort only gets you a small gain. But it may have some benefit, or it might even be necessary. So understanding and weighing the difference between those things that might be simple and those things that might be difficult in terms of programmatically creating some drawing automation is that's a great responsibility for you as end users, or as a company that might want to implement drawing automation. And what I mean by that is, does it get you a benefit if you fully flesh out a drawing automation project? Meaning, I'm going to place sheets, I'm going to place views, parts lists, balloons, and dimensions. The amount of effort involved in that may be substantial enough where you may say, okay, I'm just going to create some automation that puts together all the sheets I need for a particular configuration. And then it's going to lay down the views, and it's going to scale them, and throw down a parts list and a bill of material and a border and things like that. But I'm going to allow my end users to place those dimensions or balloons because they have the wherewithal, they have the intimate knowledge of our designs to rapidly do that. And it's not as difficult for them if they already have everything in front of them in terms of sheets and views. So understanding where that balance is between those things that are simple and those things that are difficult in terms of the amount of effort or the level of effort required is also a very important part of your planning process when it comes to Inventor automation.